Hi, this is Professor Soung Liew. I'm going to give you a short introduction to this technology called physical layer network coding, which we developed at the Institute of Network Coding. So what is physical layer network coding about? Well, I'm sure many of you have Wi-Fi routers at home to connect your computers or iPhones or Android phones to the internet. Now, when more than one devices transmit together to your Wi-Fi routers, that will create interference. And as a result, your Wi-Fi router may not be able to detect any signals from the Wi-Fi devices that transmit simultaneously. In a neighborhood where there are a lot of Wi-Fi routers, they may also interfere with each other. So the conventional view is that if there are too many devices and there are interference is bad. It causes this disruption in the operation of your Wi-Fi network. Now, if you think more deeply about that, is interference that bad? After all, radio signals are electromagnetic waves. When there are multiple electromagnetic waves, they superimpose and they add. Those of you who have a physics background in your high school, I'm sure you have done this experiment called two-slit experiment, where you have a light source with light passing through two slits, and then it creates some sort of interference patterns at the screen. And that is the result of the addition of electromagnetic waves. Same with radio waves. Radio waves are also electromagnetic waves. So the idea of physical layer network coding is to exploit the additive nature of interfering signal to turn interference into something good so that you can actually speed up the operation of your network. A simple example of illustration is this network called two-way relay network. So suppose you have two stations, A and B. A wants to send a message, SA, to B. And B also wants to send a message, SB, to A. However, suppose A and B are too far away from each other to communicate. So they need to go through a relay. In order for A to send this message to B, this message, SA, has to pass through the relay, and then the relay will transmit to B. And B will send SB to relay, and relay will pass it to A. A real-life example could be a satellite network. This relay could be up in the sky in a satellite. And A and B are two ground stations that wants to transmit messages to each other, but they are not within the range of each other, so they have to communicate through the satellite. So how they might do that? How much time do they need in order for them to exchange one message with each other? Okay. The question we ask is how many transmissions are needed for them to exchange one message? Well, if you think about it, a simple way is just what I related just now. A will send SA to R. This is transmission 1. R will then send relay SA to B. This is transmission 2. B will send SB to R. And R will relay that to A. So altogether, there are 4 transmissions. Can we do better? Well, if you think about it, if A and B were to be very close to each other, then they do not need a relay. Then A can send SA directly to B, B can send SB directly to A. Altogether, you only need 2 transmissions. But now they are out of range with each other, they have to go through the relay. Can we still do 2 transmission only in order to exchange these 2 messages? Well, if you think about it, a straightforward solution is the following. So this is what we mean by communication by network coding. So first transmission, A will send SA to R. And then in the second transmission, B will send SB to R. Now this is where things get interesting. By network coding, we mean that when the relay receives SA and SB, it doesn't just forward SA and SB to B and A. It performs an operation. It adds together SA and SB. If this were a computer inside, it will perform computation to add these two signals together, and then we broadcast it back to A and B. It doesn't broadcast SA or SB. It broadcasts instead the sum of SA and SB as SR. So if this were a satellite, when it transmits, both A and B will hear SR. So what happens at A, if you think about it, if A really wants to have SB, because SB, this is the original message from station B, but it receives SR. However, A knows SB, so it can subtract SA from SR in order to get SB, and therefore obtain the message from B. You see, SR is equal to SA plus SB. If you subtract SA from it, which A already knows because this is its own message, it can get message from the other side. Same thing with B. When you receive SR, it can subtract SB from it in order to get the message from the other side. With network coding, you reduce the number of transmission you need from 4 to 3. But we want to aim for 2. Physical layer network coding allows you to do that. How does it do that? Well, you let A and B transmit together. If this were Wi-Fi, it would not work. But we know that when SA and SB in the form of electromagnetic wave come together, they actually add in the air over here. So if R could detect the addition, then it can do something. In particular, it can detect the addition. It just transmits the addition back together in transmission 2. You see, in transmission 1, we let A and B transmit together in both directions. R received the overlap signal in the form of SA and SB, and it just rebroadcasts whatever it received back to A and B. And of course, A can perform exactly the same thing as before in the previous slide to get SB, and SB can perform the same operation as before to get SA. So all these are good in theory. Does that work? Well, in Institute of Network Coding, we have built a prototype on this radio board and which interface to computer using the software-defined radio. So again, A and B will transmit together to this relay, and this relay will broadcast the SR back to A and B. So in the lab, A and B are not so far from each other. If this were a satellite network, the antenna would be very big, and SB would be very far away with a very big antenna. This R will be up in the sky in the satellite. So with physical layer network coding, we basically can double the speed because we reduce the number of transmission needed from 4 to 2. Thank you for listening to my short introduction of physical layer network coding.